Welcome to today's episode, where we delve into a groundbreaking announcement that's been making waves across the globe. Elon Musk, the visionary behind SpaceX, has recently made a startling declaration. Oumuamua is on a direct collision course with Earth, and it's not stopping. In the next few minutes, we'll break down everything you need to know about this mysterious space object, what Musk's announcement could mean for humanity, and how the world is reacting to this impending cosmic event. Stay tuned as we explore the depths of the unknown, right here, right now. 7 years ago, astronomers stumbled upon an intriguing object as it made its way through the inner solar system. Its path was a slingshot trajectory around the sun, propelling it back into interstellar space. This fleeting visit allowed researchers only a brief period, a few weeks, to observe Oumuamua before it disappeared from sight, leaving a trail of unanswered questions. Even now, over 7 years since its discovery, scientists are still trying to decipher the limited data they collected, particularly the observations showing Oumuamua accelerating away from the sun faster than could be accounted for by gravity alone. Contrary to all expectations, it seemed as if the object had accelerated, akin to a startled driver speeding away from an unsavory area. In an astonishing development, Elon Musk, the CEO of Tesla and SpaceX, has recently announced that this enigmatic object is on its way back. This revelation brings us back to the unresolved mystery of its origins. Could it be that this visitor is not a comet or asteroid, but something far more extraordinary, an alien spacecraft? Instead of a mere rock drifting through the vast emptiness, might we be looking at the remnants of an ancient extraterrestrial vessel? In today's episode, we delve into the wonders of a starship powered by the grandeur of light itself. Billions of years ago, our solar system presented a starkly different landscape from the one we are familiar with today. Earth was devoid of multicellular life forms, lacking plants, animals, and the process of sexual reproduction. Saturn's iconic rings were non-existent, as the catastrophic collision that would obliterate one of its massive moons had yet to occur. Moreover, the asteroid belt was teeming with rocky bodies, many of which have since been expelled into interstellar space due to gravitational forces. According to our understanding of solar system formation, this narrative is not unique. Small rocky and ice-dominated bodies located further away are often displaced by the gravitational pull of nearby planets and objects, causing them to be flung across the galaxy. Eventually, some of these wanderers randomly drift into the gravitational influence of another solar system. In 2017, we witnessed a groundbreaking discovery, an object traversing our solar system that originated from beyond its bounds. Named Oumuamua, a Hawaiian term meaning scout or messenger from the distant past, this interstellar visitor captivated our attention for its unparalleled characteristics, unlike anything previously observed. Every object discovered within our solar system follows an orbit around the sun, which can be classified into one of 4 types based on its eccentricity: circular, with an eccentricity of 0, elliptical, with eccentricity between 0 and 1, parabolic, with an eccentricity exactly equal to 1, or hyperbolic, with an eccentricity greater than 1. We have encountered objects in all these categories, with those in the hyperbolic class typically being comets that have been gravitationally propelled in such a way that they are on a path to leave the solar system. These comets exhibit eccentricities slightly over 1, such as 1.1. However, Oumuamua stood out as a significant anomaly when it was discovered. Its eccentricity was measured at 1.2, distinguishing it dramatically from every other object we have identified. To grasp the extent of its uniqueness, consider its velocity as it exited the solar system. For a Kuiper belt object influenced by a large body beyond Neptune, or directly by Neptune, it might be ejected from the solar system, attaining a hyperbolic orbit. Yet, its exit speed would typically not exceed about 1 km/s. The same applies to an asteroid influenced by Jupiter, which might achieve exit speeds of a few kilometers per second, but no more. In contrast, Oumuamua's departure speed was unprecedented, marking it as an extraordinary find in our continuous exploration of space. As it exited the solar system, Oumuamua's velocity was recorded at an astounding 26 km/s figure, far beyond what is expected for objects originating from within our solar neighborhood. This implies that Oumuamua must have come from beyond our solar system, likely having been expelled from another star system, marking its origin as interstellar and enigmatic. The universe, teeming with countless stars, likely hosts billions of such objects. It's highly probable that many traverse our solar system yearly, yet Oumuamua was the first to be detected. Its journey brought it closer to the Sun than Mercury, a path that eludes most telescopic observation due to the proximity to the Sun's glare. It wasn't spotted until it had passed Earth's orbit on its departure from the solar system. The discovery occurred when Oumuamua was nearly at its nearest point to Earth, at a distance of about 23 million kilometers, approximately 60 times the distance from the Earth to the Moon. At its closest approach, it reached a peak speed of 88 km/s, roughly triple the orbital speed of Earth around the Sun, showcasing its incredible velocity as it continued its journey through space. Despite the challenges, it was incredibly fortunate that we managed to extract Oumuamua's data from the observations. However, as Oumuamua neared the Sun, its high velocity meant it remained within the observable region for our telescopes for only a short time. Consequently, astronomers had a limited window to collect data on this intriguing interstellar visitor, and they are now analyzing the information gathered during those few months to uncover as much as possible about. Initially, observers believed Oumuamua, measuring approximately 800 meters in length and 80 meters in width, to be an asteroid. Yet, a study led by Marco Micheli in the journal Nature revealed that Oumuamua's movements were anomalous. It exhibited significant non-gravitational acceleration, indicating that forces other than gravity were influencing its trajectory. Karen Meach from the Institute for Astronomy at the University of Hawaii pointed out that various factors could contribute to such acceleration. Meach and her team explored at least 6 potential causes for this behavior, dismissing several hypotheses that either made Oumuamua too peculiar to be plausible or failed to align with the observed acceleration patterns. Upon analyzing the data, the research team determined that the most plausible explanation for Oumuamua's unusual movement was comet outgassing, a phenomenon commonly observed in comets. Outgassing occurs when a comet approaches the Sun, causing the heat to sublimate the icy compounds on its surface directly from solid to gas. This release of gas can propel the comet, altering its speed and rotation in a way that deviates from purely gravitational movements. The intensity of Oumuamua's non-gravitational acceleration was consistent with what is typically observed in comets, which initially did not raise suspicions. However, the absence of visible dust being expelled from Oumuamua was peculiar. Normally, as gas escapes a comet, it drags along surface dust. The strength of the outgassing can even dictate the size of the dust grains that are liberated. This observation did not entirely dismiss the comet hypothesis, according to Karen Meach. She suggested that while Oumuamua might have lacked small dust particles, larger dust could have been ejected from its surface, influencing its trajectory. Larger dust particles are more challenging to detect at the visible wavelengths used by astronomers, which could explain why no dust was observed. Yet, the mystery deepened with the absence of detectable gas emissions from Oumuamua. This lack of evidence for gas, alongside the missing dust, was particularly puzzling since a significant amount of gas would be needed to account for the observed changes in Oumuamua's motion. The significant point to note is that Meach's team specifically searched for CN gas, which is luminous and readily detectable. Meach explained that CN gas is typically released from comets in our solar system as water vaporizes, making it a useful indicator for water, which is more difficult to detect directly. However, their observations revealed no presence of CN gas down to their detection limit, suggesting an unusual chemical composition for Oumuamua. This absence indicated that, if water was being released from Oumuamua, it was not in quantities significant enough to detect, marking Oumuamua as chemically distinct from the comets within our solar system, which often contain abundant water. Given that Oumuamua likely originated from another solar system, its unique chemical and physical characteristics might not be as surprising. These differences could simply reflect the diversity of interstellar space. The mystery of Oumuamua's origins remains unsolved. Its trajectory around the Sun confirms it is not a local object. Comets within our solar system generally originate from the Oort cloud, a distant region still gravitationally bound to the Sun, while asteroids are primarily found in the belt between Mars and Jupiter. Oumuamua's path indicates it could not have originated from these regions. As the first interstellar object observed so closely within our solar system, Oumuamua's behavior and composition offer valuable insights into planetary formation and the movement of objects between star systems. Its study presents an unprecedented opportunity to learn more about the universe beyond our immediate cosmic neighborhood. Even if it's not extraterrestrial in origin, Oumuamua's existence is still a remarkable discovery. The hope that it might be of alien origin ties into the larger metaphorical idea that it could be a sign of a more wondrous, mystical universe than previously imagined. Before Oumuamua's appearance, scientists believed interstellar objects to be exceedingly rare. Echoing the words of the esteemed author, Douglas Adams, the universe is unimaginably vast, making the likelihood of encountering extraterrestrial life slim, despite the universe's immense size. However, the unexpected visit of Oumuamua to our solar system hints that interstellar objects might be more common than thought, perhaps passing through as often as once every 30 years. Observations of Oumuamua's brightness and reflectivity indicate an elongated cigar-like shape, leading some to speculate that it might have been ejected from another solar system, potentially stretched by the gravitational pull of a planet similar to Jupiter. The questions that arise from Oumuamua's presence are even more intriguing. If it's an asteroid, why does it follow a comet-like orbit? If it's a comet, why is there no visible tail? And why doesn't it exhibit typical cometary outgassing? And why is this cigar-shaped object accelerating in a manner that defies conventional understanding? These mysteries underscore the excitement and curiosity that Oumuamua has sparked among the scientific community. The speculation surrounding Oumuamua has ignited the imaginations of those hopeful for extraterrestrial life, propelling their theories at breakneck speed. The notion of a cigar-shaped spacecraft is not new to the realms of science fiction, with iconic examples like Rama, the Doomsday Machine, the heptapod shells, the Nauvoo behemoth, the Medina Station, Zentradi warships, and the Infinity populating popular stories. This intrigue extends beyond mere online forums. Even esteemed physicists are contemplating the possibilities. Harvard astrophysicists Avi Loeb and Shmuel Bialy have contributed to the discussion with their publication in the Astrophysical Journal Letters, suggesting that Oumuamua might be a light sail from advanced technological equipment adrift in interstellar space, or more intriguingly, an operational probe sent deliberately close to Earth by an alien civilization. This hypothesis, while captivating, has met with caution within the scientific community. As Carl Sagan famously articulated, embodied here by the sentiment from Ahsan Omer of Cornell University, extraordinary claims require extraordinary evidence. And with Oumuamua having exited the solar system, the opportunity for direct investigation has slipped away. Loeb, who has been a vocal proponent of the artificial origin theory, also serves as the chair of the advisory committee for the Breakthrough Starshot Initiative, indicating his vested interest in the exploration and understanding of interstellar objects and propulsion technologies. This connection underscores the broader scientific and imaginative engagement with the mysteries of Oumuamua and the universe at large. The initiative to develop a spacecraft powered by solar sail technology, akin to what Loeb speculates Oumuamua could be, is financed by Yuri Milner, a venture capitalist with Kremlin ties. However, Loeb's association with this project does not invalidate his theories. As Loeb explained to the Israeli newspaper Haaretz, consider how a caveman might react if shown a modern smartphone. They would likely view it as a peculiar rock, not understanding its true nature or capabilities. In this analogy, Oumuamua is likened to the iPhone, and we, with our current scientific understanding, are the cavemen. Even the most forward-thinking scientists, who are the cavemen's visionaries of reason, might dismiss it as just another rock, not recognizing its potential significance. This does not imply that scientists are uninterested in discovering extraterrestrial life. On the contrary, the search for alien life forms is a significant and exciting field within the scientific community. In 1959, physicists Giuseppe Cocconi and Philip Morrison published a groundbreaking paper in Nature titled "Searching for Interstellar Communications," which proposed the idea of looking for signals from alien civilizations as a serious scientific endeavor. Their paper suggested that our planet, and by extension, human civilization, could be detectable by alien observatories. This leads to the possibility that if other intelligent beings exist, they might be attempting to communicate with us, positing that such civilizations could have been broadcasting signals long before our time. In their pioneering work, Cocconi and Morrison envisioned a method of establishing a communication channel that, if discovered, could bridge the gap between us and extraterrestrial intelligence. This concept laid the groundwork for the modern search for extraterrestrial intelligence, SET, proposing a tangible scientific approach to scan the cosmos, much like tuning an analog radio to find a specific frequency that might carry a message from alien civilizations. This approach remains a cornerstone of SETI research. Our universe is awash with radio waves traveling at light speed, emanating from various sources, including star collapses, the auroras on gas giants, and human-made communications technologies. Essentially, any process that induces rapid electron movements can generate radio waves. These waves, each carrying distinct information about their origin, allow scientists to distinguish between signals of natural phenomena and potential communications from advanced civilizations. Natural sources tend to emit across a broad spectrum of frequencies, creating a sort of cosmic background noise. Jason Wright, an astronomer at Penn State University, explains that these natural emissions have specific patterns or fingerprints, broadcasting over a wide range of frequencies. This characteristic enables researchers to differentiate between the cacophony of natural cosmic radio emissions and potentially artificial signals, which might appear on the cosmic radio dial as more focused, deliberate broadcasts indicative of an intelligent origin. An alien transmitter sending out a focused signal would be markedly different from the broad spectrum of natural radio emissions. This is analogous to how humans use radio technology. To listen to a specific station, one must tune into a precise frequency. This is the essence of Radio SET. I search for extraterrestrial intelligence. Research searching for transmissions that occupy a narrow frequency band, which Jean-Luc Margot, a radio astronomer and technosignature researcher at the University of California, Los Angeles, points out as something nature alone cannot achieve. Isolating a transmission to a specific, narrow set of frequencies typically requires technology, making the search for such signals quite direct. As Michael Garrett, director of the Jodrell Banks Center for Astrophysics, explains, the goal is to find signals that do not match the usual patterns emitted by stars and galaxies, essentially seeking out anomalies in the cosmic noise that nature would not ordinarily produce. However, distinguishing these potential technosignatures from natural cosmic phenomena is not without its challenges. Nature has misled astronomers before, as illustrated by the discovery of pulsars. Initially, when pulsars rapidly spinning, highly dense remnants of stars that emit radiation beams from their poles were first detected in 1967 and later identified in 1968. Their consistent, pulsing signals confused scientists. Before their nature was understood, the precise, regular bursts of radio waves they emitted led to some speculation about their possible artificial origins. This history underscores the complexity of identifying truly artificial signals amid the cosmos's vast and varied natural radio emissions. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.